How do you drag select? How do you manage selection of multiple units in an RTS-style game? If you have these questions, this is the video for you. Hey, Chris here from LlamAcademy, here to help you, yes, you, make your game dev dreams become a reality. Today's part 26 of the AI series, where we're going to talk about selecting multiple units and moving them on a nav mesh. We're going to implement this by allowing you to drag select multiple units. We'll also let you point and click to select single units, shift point and click to add or remove units from your selection, and we'll also have it where you can click to remove all selections. Of course, just selecting units isn't particularly interesting, so we'll have it where you can right-click to move them, just as you would expect in any RTS game. I'll also discuss some of the caveats and maybe gotchas that if you're not really careful of whenever you're doing the drag select, you could really not understand what's going on. I know I had a little bit of trouble with this myself when I was making this video. And before we go any further, I just want to give a huge shout out to everyone who's supporting me on Patreon right now. I really appreciate it. Every bit helps the channel grow, reach more people, and add value to more people. And that means more people are making their game development dream become a reality. If you want to help me in that cause, you can show your support on Patreon, patreon.com/LlamAcademy. You can get your name up on the screen, you can get a voice shout out starting at the silver tier, and some other cool perks. Special shout outs to Raphael for being the silver supporter. I'm so grateful for that next level support. Thank you. You can see here we have 3 units. They're all a prefab, so they're all configured the same way. The important thing is whenever we added the nav mesh agent, I set the stopping distance to be 1. Everything else is the default. If I show the navigation panel, you can see I only have one agent configured. It's called player. They have a radius of 0.25. Most of this is default anyway. If we open up the project settings and go to the tags and layers section, we'll add 2 new layers, one called units and one called floor. I'll then open up the unit prefab and change the layer to be on the units layer. The unit has a child object called selection sprite, which is just a circle that's blue with a sprite renderer. In the scene on the floor, we'll attach a nav mesh surface, make it collect objects children, and then bake it so our nav mesh agents can walk around. And we'll make sure that the floor is on the floor layer. I'll then create 3 scripts: selection manager, player input, and selectable unit. If we hop over to Visual Studio, we'll start with the Selection Manager. This is going to be the singleton class that we use to manage which units we have selected, so that way we can issue orders to them. So we will make sure that this class does not extend the mono behavior. This is going to be just a normal C# class. We'll make a private static selection manager _ instance, a public static selection manager instance, and the instance property will say it has a getter and a setter. The get will check if _ instance is null. If it is, we'll create a new instance and then return that instance. And we'll have the private set. That way only this class can construct itself. We'll also make a private selection manager constructor. So again, only this class can construct itself. We'll then create a public hash set of selectable units called selected units. Set that to be a new hash set by default, and create a public list of selectable unit called available units, and also set that to be a new list by default. So a hash set makes it so it's unique items in the list, guaranteed. And a list is a little bit more friendly to refer to things whenever we're going to iterate over them, because sometimes I may want to run a normal for loop to get something by index, doing like for int I = 0, I less than available units count, and then get each one of those instead of using a for each loop. Realistically, you could set both of these as a hash set. Let's add some public utility methods to make it more convenient to utilize these lists and sets. We'll add a public void select, selectable unit that just has selected units.add the unit. We'll have a deselect, which is public void deselect selectable unit, and that just removes that unit from the selected units set. And then let's do a deselect all, and there we'll just do selected units.clear. We hop to the selectable unit now. We'll make that require component type of nav mesh agent. Add that private nav mesh agent and a private serialized field sprite renderer called selection sprite. On awake, what we'll do is make this selectable unit register itself with the selection manager by doing SelectionManager.instant.availableUnits.add this. We'll also get a reference to that nav mesh agent that's on this game object. And let's add a public void move to. It accepts a vector3 position, and we'll just do agent.setDestination position there. And we'll make a public void onSelected that we'll call whenever this gets selected. And we'll do any logic that we want this object to do whenever it gets selected. Maybe you want it to play an audio clip. You can play an animation instead of just turning on this sprite renderer, something like that. Anything that you need to do whenever it gets selected, put it here. And we'll do the inverse as well, public void on deselected, where we just disable that sprite. And since we want to do these on select and on deselect, what I'll do is on deselect, before we remove the unit, we will do unit.onDeselected. And on select, after we've added it, we'll do unit.onSelected. And in the deselect all, we actually need to iterate over all of the selected units and call onDeselected there. So we'll do for each selectable unit in selected units, and we'll do unit.onDeselected, and then we'll clear that hash set. And I'm going to add just one more utility function here. Public bool is selected, selectable unit that we just returned, selected units.contains unit. Now that we have a selection manager that manages our selectable units, let's actually use that selection manager to manage which ones we got selected with the player input class. We'll add a private camera that's a serialized field. Because we're doing a top-down thing, we're going to do some raycasts from the camera. We'll do a private rect transform selection box, a private layer mask unit layers, a private layer mask floor layers, a private vector2 start mouse position. We're going to first work on the drag select because that's kind of at least for me, it was the harder one to understand. The point and click to select is fine. I already knew how to do that, but the selection was the one that was a little bit more tricky for me to figure out. So we're going to start with just that one. So to do a selection box, you need to understand where you started from, and then we're going to resize this rect transform based on the mouse movement every frame. So in update, because there's kind of going to be a lot of logic around actually doing this drag selection, I'm going to just put handle selection inputs, and then we'll define that private void handle selection inputs just to separate out this so we don't have this gigantic update function. We'll do if input.getKeyDown keycode.mouse0, that's the left mouse button. So whenever the mouse button first goes down, we'll say the selection box size delta is vector2 0, so that way we don't see any residual value from the previous time. And we'll set the selection box game object to be active. We'll also set up the start mouse position to be the current mouse position. We'll then check else if input.getKey keycode mouse0, so if the mouse button is still held down, then we will resize that selection box. And then again, else if input.getKey up, meaning we have let go of the mouse button, then we will resize the selection box to be, again, vector2 0, and we'll disable that game object. And you see here we're following kind of straight down the list of when the user first clicks, when it's held down, and then whenever they let go. So let's go to the resize selection box. Let's make that private void resize selection box. Let's find out the size that we want the selection box to be. That'll be float width equals input.mouseposition.x minus the start position.x, and the height would be the same thing for the y. We're going to anchor our selection box to be at the start mouse position plus half size of the box. And then we'll set up the selection box size to be the size that we just had. So we'll do selection box.size delta equals new vector2 mathf.abs as absolute value. So if width is negative for some reason, we're not going to have a negative size. We're just going to coerce that to be a positive value. And the same for the height. We'll do mathf.abs height. Because the mouse input comes from the bottom left of the screen, whenever we set up our canvas with a selection box, we're going to anchor that selection box from the bottom left. That way our input mouse position and our anchored position will be the same point. And generally, whenever you're using the Unity UI, the pivot point is the center of the image, meaning we need to take half the size of it into account. The math that you do for resizing the selection box really varies depending on how you have your canvas set up. The way we're going to do it is have the canvas scaler set to constant pixel size, and that makes it so the canvas keeps the same scale all the time. That's really important that we have it configured that way, and I'm going to talk about it again later. But if you do a canvas scaler that is not constant pixel size, you need to also account for what is the actual size of the canvas versus the screen size. So you'd have some different math here. My personal recommendation is how we're going to do it in this one is have a canvas that is specifically for the selection box that is constant pixel size. So you don't have to worry about the rest of your UI interfering with your selection box. Now that we've resized our selection box, let's create some bounds so we can compare where our units are in screen space compared to our selection rectangle. Bounds equals new bounds, where we put in the selection box dot anchored position as the center and the selection box size delta as the size. Since we have our selection box pivot set at the center, this is perfect, all we need to do for the bounds. Then we'll iterate over the available units using for int I equals 0 I less than SelectionManager.instance.availableUnits.count, incrementing I by 1. And we'll check if the unit is in the selection box, passing in Camera.WorldToScreenPoint. This is the one critical method that we need to understand for how to make the selection box work. That converts a unit in world space to our screen space coordinates, so we can then check if that falls within the bounds that we just created for our selection box. All we have to do there is pass in the world space coordinates of our unit. So SelectionManager.instance.AvailableUnitsIndexedBy.I.transform.position, and our UnitIsInSelectionBox will also pass in the bounds as a second argument. If that returns true, if our unit is in the selection box, then we'll do SelectionManager.instance.select and then pass in the unit that we're talking about, the available units indexed by I. If the unit is not in the selection box, then we will deselect that unit. So one thing I want to make sure it's really clear here is we are selecting before the user lets go of the mouse, because we want to show that hover effect. If you want them to release the mouse before you actually do the selection, you would need to manage a different list of which objects have been selected in this function, and then on release, in the last condition of our handle movement inputs, you would then select all the units only after they've let go. You can see on the screen right now the code that I did that will do selection only if you release the mouse button, not as you're dragging. That may be a more desirable effect for you, so consider if that or the drag and select at the same time is the functionality that you want in your game. So far we've not defined this unit is in selection box, so let's define that private bool unit is in selection box, vector to position, and bounds. We'll just return that the position.x is greater than the bounds.min.x, and position.x is less than bounds.max.x, and do the same thing for the y. Position y is greater than the bounds.min.y, and position.y is less than bounds.max.y. If we hop back to the Unity editor, open up our unit prefab, we will attach the selectable unit script and drag the selection sprite to that selection sprite reference. On the main camera, we'll attach the player input, set the unit layers to units, set the floor layers to floor, drag the camera reference, and we have not created our selection box, so we'll do a right-click create UI image that automatically adds us a canvas and an image. If I swap to the 2D view, set the image to be at 0, 0, and I'll attach this UI sprite that's default from Unity. It has that kind of black border. I'll change the color to this blue and make it a little bit more transparent, maybe 144 alpha. And as I was saying earlier, it's really important that we change the anchor position to be the bottom left, not the center. I'll rename it to be selection box, and I'll drag the reference to the player input. The really important thing again on this canvas is that the canvas scaler needs to be constant pixel size. If we change it to something that is a scale with screen size, you'll see that the scale of the canvas actually changes based on the size of our reference resolution and whatever we're actually rendering. That makes it where we have a lot more math to do to figure out if our units are in our selection rectangle to convert them to whatever the size of the canvas is. So keeping it at constant pixel size just makes everything a lot easier. If we click play, I can then drag and select. We'll see the rectangle goes wherever I am, and as I go over a unit, we'll see that circle comes in, so we know that they are selected. But the challenge here then is I can't click on these units. I have to drag select. So how do we implement a click and select with our drag select? We'll hop back to Visual Studio, add a private float drag delay 0.1f by default, and serialize that. We'll also put a private float mouse down time. This is important because we want to delay the resize selection box portion of our handle selection inputs, because remember that loop will deselect everything that's not in the selection box. So we don't want to go down that path if we're just point click to select. In handle selection inputs, we'll just set the mouse down time to be time.time in the input.getKeyDown block, the first block, and then we'll update our if about if input.getKey, so whenever they're holding it, to say and mouse down time plus drag delay is less than time.time. And then in the final block here, we'll set the mouse down time to be 0. Then how do we implement the actual click to select? Well, now we know we're going to skip the resize selection box if they're just clicking, so we'll hit input.getKeyDown and then input.getKeyUp, skipping the middle one. So in the get key up is when we would actually like to select something. In here, we'll do if physics.raycast camera.screenPointToRay input.mouse position out raycast hit and the unit layers. So we want to raycast only on the unit layers. If that hits something, I'll say and hit.collider.tryGetComponent selectable unit out selectable unit. So both of those are true. If we hit something, we got the reference to a raycast hit. We check if that has a selectable unit on it, which it should. We get that reference to the selectable unit. If input.getKey key code left shift or input.getKey keycode right shift, usually use the left shift or the right shift to add to your selection or to remove from your selection if they're already selected. So that's what we're going to implement here. So if the left shift or right shift is held down, we'll check if this unit is already selected. If it is, we will deselect it. If it's not already selected, we will select it. And if we're not holding down either shift, then what do we want to do? We want to only select that one unit that we just clicked on. So we'll deselect all and then we'll select that one unit. And the last scenario we want to consider is what if you click, but you don't click on any unit? In that case, you're probably trying to deselect stuff. So we'll say, if mouse downtime plus drag delay is greater than time.time, then SelectionManager.cs.Deselect all. This case is to prevent us from accidentally deselecting all if we are doing the drag select. If we've just clicked very quickly without dragging, then we'll deselect everything. If we hop back to the Unity editor and we start just clicking on our units, we'll see they get selected when I'm holding shift. They get deselected when I just click on one of them or totally off the grid. And it still works with our drag select. I can drag select to select them and I can shift click to deselect them. That's perfect. But if I try to move them, nothing happens. We can select things, but we can't do anything with them. So let's hop back to Visual Studio real fast and implement the click to move for multiple agents. In Update, we have handle selection inputs. So we'll add handle movement inputs. Then we'll define private void handle movement inputs. We'll say if input.getKeyUp, keycode mouse 1, that's the right click. And we'll also check if the selection manager instance.SelectedUnits.count is greater than 0 because raycasting isn't free. We won't do any raycasting if there's nothing selected because we won't do anything anyway. We'll do a physics.raycast, Camera.ScreenPointToRay, input.mouse position, out raycast hit, and then this time we'll pass in the floor layers because we want to check on the floor for where we should move. And then we'll just iterate over all the selected units for each selectable unit in SelectionManager.instance.SelectedUnits. In there, we'll say unit.moveTo and then the hit.point. So very much the same as what we did in AI series part 1 with the click to move, very much the same as what we did to point and click select. There should not be any really big surprises here. If we hop back to the Unity editor, if I right click, all of the units move to wherever I'm clicking. If I only have one selected, I can control one at a time, right click to move them. I can drag, select, and move. It works just like you would expect any RTS to work. If I leave the play mode and duplicate all of these units, so we have a whole bunch of units now, it shows you a little bit more interesting where I can drag select different groups and control them like that. The drag select still works no matter how many units we have. I can point and click to move individual units. The other thing, you'll see that the agents don't keep kind of fighting to try to get to wherever I clicked. That's because of that stopping distance of 1. Whenever they get within 1 unit of wherever they were asked to go, they will stop trying to fight each other to get closer. We now have the fundamentals required to make an RTS game. That's pretty cool. I hope you got a lot of value out of today's video and you understand how to implement a drag select, understand the gotchas that can maybe mess up your drag select, and also do point click selection and how to move multiple NavMesh agents using this selection manager we've implemented. If you have been getting value out of this video or the series, please consider liking and subscribing to help the channel grow, reach more people, and add value to more people. This new video is posted every Tuesday and sometimes on other days too. If you have any questions, if you have a suggestion for a topic, or if you're implementing AI into your game, drop a comment down below, and I'll see you on the next video.